It was 1965. A chemist was running a routine experiment, trying to make a stronger, lighter plastic for car tires. She mixed two chemical solutions together, and instead of the liquid she expected, the mixture seized up. Instantly, the stirring rod stopped dead. She pulled it out slowly, and the material stretched into thin, golden fibers. She pulled them. She bent them. She tried to cut them. She couldn't. Her name was Stephanie Kwolek. She was 35 years old, working alone in a DuPont laboratory, and she had just accidentally created a material 5 times stronger than steel that weighed almost nothing. She had no idea what it was for. Turns out, it was for stopping bullets. Stephanie Kwolek had actually planned to use her chemistry salary to save up for medical school. Chemistry was supposed to be temporary, but the lab got under her skin. The puzzles kept her there. In 1964, she was given an assignment that seemed completely unremarkable. DuPont needed a strong, lightweight synthetic fiber to replace heavy steel in car tires. Kwolek's job was to find it. Methodical, painstaking work. Most experiments produced nothing interesting. Then came the one that didn't. One day, Kwolek produced a polymer solution that looked completely wrong. Cloudy, thin, almost watery. In chemistry, cloudy solutions mean one thing: contamination. Throw it out, start again. Her colleague told her exactly that. But Kwolek had a feeling. She couldn't explain it. Not scientifically, not logically. She just didn't want to throw it away. She convinced the lab technician, who almost refused, to run it through the spinning machine anyway. It produced thin, golden fibers. She tested their strength. The numbers came back impossible. 5 times stronger than steel. Almost weightless. She ran the tests again. Same results. The fiber was just that strong. Nobody immediately thought about bulletproof vests. For the first few years, Kevlar was used in racing tires. But the material's properties were impossible to ignore. Then someone asked the question that changed everything. What happens when a bullet hits this? When a bullet strikes woven Kevlar, the fibers absorb and disperse the energy across a wide area. The bullet slows. It gets caught. It doesn't go through. By 1975, the first Kevlar vests were in field testing with police departments. Officers wore them on duty. Real bullets were fired at real people wearing this material. And they lived. Today, over 3,000 police officers in the United States alone are estimated to have survived gunshot wounds because of Kevlar. Stephanie Kwolek never set out to save anyone's life. She was trying to help cars use less gasoline. She was once asked what the secret to her discovery was. She said, "There are no accidents in science. There are only unexpected results. The question is whether you're paying enough attention to see them." That cloudy solution sat on her workbench. Every other chemist would have thrown it away without a second thought. Kwolek looked at it and thought, but what if? That question is the reason thousands of people are alive today who otherwise wouldn't be. Subscribe, because next time we're going into another accidental discovery that started in a laboratory and changed the way the entire world thinks about infection.